Hello, my name is Evgeny Cherkashin, and I would like to present my talk to Commander Systems, Technical Decisions and Lesson Learned. This is a joint work of Matrosov Institute of System Dynamics and Control Theory of Siberian branch of Russian Academy of Sciences and National Research Irkutsk State Technical University. Commander systems are examples of decision support systems, and they are very useful to focus users on objects they're interested in. For example, we will consider two application domains. One is real estate of a region, I mean Irkutsk region, where I live, helping with selling Realty. And the second one, which is on the beginning stage of development, is devoted to specialty choosing of a high school for entrance. Both systems were developed within master degrees at Institute for Information Technologies and Data Science. The first system deals with selling flats, houses, garages, rooms, but the interesting aspect is to supply realty offices with support in selling special cases like hotels, countryside houses, shops. The problem is here that sellers have to pay taxes for unprofitable property, but some buyers having a big amount of money cannot invest it or save it. The second recommender system for entrants are to obtain perspective specialty, comfort to entrance nature. In compared to the previous domain, there are no special industry or informational systems supporting career guidance. We have only informational services at hand, and students or entrants could use neighbors, parents, or other related subjective experience to construct their decision. For the universities, it would be of purpose to focus their activity to the target audience, to supply students with relevant optional courses, or even to develop new courses. On this slide, we summarize related works, review, and the main problem researchers paying attention to is a cold start problem. This problem arises when the recommender systems start functioning, when there is no information about the user's properties and their interest in object they would like to buy. The following experience were acquired. First, the real estate recommender system developers sometimes attract sellers to be expert of content filtering. In this case, sellers describe their property for buyers, emphasizing special cases and everything they would like to emphasize. Special data of realty's surroundings are also estimated. For example, when somebody would like to buy a flat, he or she account neighbor service, schools, kindergartens, shops. Sometimes problem is stated as a game or control theory. For example, there was a paper where researchers try to organize activities to satisfy the most customers and sellers. For entrant-like recommender systems, we found that the main sources of information are grades which gained by a school student, and these grades were used to account their interest as university students. One system tried to predict grades for courses they potentially could attend to. Another work dealt with predicting learning trajectories for new students by similarity to the students who studied more than 3 years. And the final set of papers was devoted to advising students with optional courses, analyzing text descriptions of the courses. Our primary aim is to apply known technique to the source data, which can be acquired in the Irkutsk region. Both systems have to be constructed with use of preliminary data processing. Real estate objects are presented as so-called classified advertisement websites. The precise data can be gained from special sites like AIIT2020, where offers stored. Each offer and realty object, which is described by properties, address, flat sizes, levels, number of rooms, etc. The data is stored in XML format, being essentially a list of offers. The users of these recommender systems have roles unknown, seller, buyer, owner, realtor, expert, and invalid user. Sellers, buyers, owners can surf the website and view realty data. Expert and realtor activities are to establish initial data, resolving cold start problem. Later in this presentation, I will describe the behavior of users, and to support this behavior, we need to distribute all the property to subclasses. The first stage is to construct these classes. We use hierarchical cluster analysis, figured out the structure consisting of the following subsets: 2-room flats, 1 or 2-room flats, which are comfort class realty, 1-room flat, dachas, houses, rooms, commercial spaces, a garage, and elite realty, flats with 3 and more rooms. Naming of the classes were performed by experts. User interest is acquired by tracking activity on website. The comparison between realty objects is made in vector space of these attributes. For example, location of a realty could be compared as 1 or 0 depending on coincidence. Price and area are comparable like a module of relative difference. For each attribute, we assign the coefficients, defining their value in the final reduction formula. These coefficients were established by our realtor expert. By means of this use case diagram, we will describe the possible behavior of users of this system. Here we have 3 main classes of users. The main role here is buyer, realtor, and experts. The realtor and experts extend buyer's activity. There are 3 main activities. The first one, view object. The second one, import data, carrying on the analysis. We could import data from realty sites or from a file. Tracking user activity when he or she views object is realized by timers. When a data page is loaded, the website timer starts, and after 30 seconds a trigger signal occurs, which is caught by special unit, and this unit fixes positive assessment of the object. In the database, it also can trigger a unit of which provides recommendation. Recommendations are made on the basis of weight slope 1 method when we have enough data, and in the other case we just use preprocessed data. For example, if we cannot use this slope 1 method, we just show random 20 objects on the same class of the object the user already viewed. The recommender system is implemented as a web application on the base of C# programming environment and ASP.NET. In Realty system, we already use Nancy, which provides very convenient way of mapping URL to a Lambda function. It is much easier than use stock ASP.NET approach. Here you can see the functional blocks of the web application. All objects in the system are represented as persistent object of entity framework. In this slide, you can see the overall structure of the database. The next two slides shows user interfaces. The first one is used to name clusters. After a cluster is constructed, for each cluster a number is supplied. After that, expert uses this interface to review the contents of the clusters and find out the common properties of the objects and name this cluster after these properties. With this interface, we also can control the amount of time spent to calculations. For example, specifying the number of objects to be randomly selected to create this cluster. This screenshot shows the result of recommendation generation. Users selected this Realty and recommendation system provided this list of objects which could be of interest. The second recommender system deals with entrants, is based on analyzing social network data. According to Tomsk State University research, most of the school students have their representation in Russian Popular in contact. The user data here is expressed by profile properties, tags and keywords characterizing groups and channels the user subscribed to. In order to implement recommendations, we have to use here content filtering and prepare data accordingly. In comparison to the previous recommender system, where user took active role to produce data for recommendations, the users of this system are passive. That means we acquire their data from social network, analyze them, and produce recommendations for university staff to focus their attention. To be more detailed, the recommendation will be produced by a neural network specially trained reflecting clusters of users to the clusters specialty objects of the university. On the first stage, which is underway, we construct classes of the users, analyzing their social network data, construct classes of specialties and courses according to their data to the competence relations. And after that, neural network will be trained to relate to these classes. On this slide, we show the list of technologies used to implement our recommender systems. Our experience shows that C# and .NET, as well as Mono technologies, are useful to construct recommender system. Although in our research we proposed the way of gathering information from user to a Realty recommender system, we tested the results on natural data used on the open source technologies. I would like to mention that our approach was to implement recommender system for regional data, and we do not take advantage of nowadays methods and research in this field. In conclusion, I would like to speak about further development of our systems. For Realty recommender system, we will, in the next master degrees, we will try to incorporate technologies based on ontologies, case-based reasoning, predictive modeling of attributes, values of realty, and one of the interesting problem statement could be based on using geospatial data. For example, for analyzing infrastructural service organizations in the nearby of the realty. Thank you for your attention. If you need my presentation, you could download it from this link. Thank you very much.